So today's case, please. Today's case will be a case where we have our forces on an inclined plane. So write for me linear ladder problem. Linear ladder problem. Do you know how I want to be starting my class now? Please pay attention. Pay attention because for linear ladder problem, do you remember when I told you that anytime I have anything slope or inclined plane, sorry, that y-axis becomes what? Y-axis becomes what? Do you still remember? X-axis becomes cos theta.
No, x-axis becomes sin theta. Y-axis becomes cos theta.
Hey, blood of God. Please, hey, you are correct, but the first time you didn't get it. Please, I hope everybody is ready to learn. Nebulu here and ask, carry it and go small back. People that want to buy it, who allow themselves, they will come and look for it. I see. If I have this to be the wall, and I say I have a ladder on it, watch, yeah? And when I am giving this ladder question, there are up to 3 cases. But for your level, this is your one level. Good? So I said, Shebi, you know this thing, I'm using this thing to represent line, you understand? So let this thing be the ground. Let this thing be the ground. And notice that there's an angle here, and there's also an angle here, do you agree? Are you aware? Please, when you are giving this question, it's either they tell you that angle is made with the wall, or they tell you angle is made with the horizontal. For a situation where they did not tell you where angle is made, you consider it that angle was made with the horizontal. And do you know that the angle here is 90 degrees? Shebi, you know? That means that if here is 60, here should be what? And if here is 60, here should be what? Some people don't know before now. Note it. I have this and I'm starting from there. And I told you that when we have an inclined plane, I've not started doing forces on an inclined plane. What I'm trying to give you now is the Mmanu method, the shortcut for whenever you see a question on linear ladder problem, the shortcut you use, then I teach you the normal method. First of all, what you need to understand is that if this ladder is leaning on this wall, there is a force acting here. Do you agree? Yes. And this force is the force on the wall pushing this ladder back. Hope you know. Understand here. When I will forcing a push here back, the ladder will just fall. Is it not true? But there's a force pulling it back. Now, on this ground, as you get the ladder, if there is no force of friction pushing this thing this way, this thing will just slip. Hope you know. Yes. Do you agree? Yes. So I have F frictional force. You notice all these things. If you go to your textbook, they did not teach you this linear ladder problem, but you will see that the last question there is on linear ladder problem on the exercises. And people last year came out second semester, they were telling me what I was seeing there was vector, slope, friction. So that is why we are taking it this time seriously. And I've gone to invent my own method. So that once you learn it, and that's it. Now notice please, do you know that everything, just as I'm standing, there's a force pushing me backward, pushing me up, are you aware? We call it normal force. That is N. So let me say this thing is wall reaction or reaction of the wall. This one is frictional force. Now, this ladder itself, do you agree that this ladder itself has weight? Shebi, you know that anything that has mass has weight. Because by the time you have the mass, acting on it downwards is that G, which is 10. You agree? Or you say mg. So, and it acts at the center. Shebi? So I will have the center of this downwards. It acts straight down. You call it mg. Hope you are learning something. Hope you are learning something. What I'm giving you are the component forces. So I am giving you that if a ladder is placed on the wall, that these are the forces acting on it. So you telling me no, is you thinking we are joking? I'm not joking about this class. So please, if you are hungry, you keep quiet. Let the people that ate respond. Please. Notice I said as this ladder is leaning on this wall, the wall is pushing it back. That's the first force. As this ladder is being on the ground, even if it tries to slip this way, provided there is enough friction on it, it won't slip because the friction is acting this way. Now, the ground itself is exerting an upward force on it. Now, because of the mass of the ladder, you don't tell me the ladder does not have mass. Because of the mass of the ladder, it has a weight. That is the mass and the force of gravity which runs downwards. So you have mg. Now the next thing to now do is to ask yourself, do you remember that when we started equilibrium, we said that it is the state of no net force. Do you still remember? No net torque and no net no net force, a state or condition of no net force, no net moment, and no net. Okay, so let's start with the force first. Let's check the forces on the left hand side and the right hand side. Let's make it to be equal. So the rule 1 first. This force here is a horizontal force, Shelly. Is it not? So RW should be equal to what? No. It should be equal to this one, Shelly. That is, remember what we said. Horizontal axis, this side should be equal to this side. If I have negative x and positive x, all should be equal to. So RW, reaction on the wall, should be equal to the frictional force. And remember I told you, stop doing that method of doing minus plus. Just do the method of left hand side to equal. To equal right hand side. Are we tired?
Yes.
Please, when I'm teaching, I like to be sure that you are following me. Because sometimes, as you teach and you just run through it, even people that are not following you, you will think everybody is following. So please, try your best to be following, to be carried along.
Hello.
Welcome.
Yeah, how are you?
It's okay.
Yeah. That's the HOD. Is there anybody in computer education? Good afternoon today. Computer education. Is there anybody in computer education?
If you are in computer education, but I doubt he's here because there are people also in MNE. Maybe it's MNE.
This is hobby.
Yes. Okay, the person talked to HOD now.
Yes, the HOD now directed me to computer.
Be good. Identify so that we'll continue. So, all academics is definitely not going on. Okay. Higher, the next thing. Notes. Look here. Let's check again. This normal reaction is pointing upwards, Shebi? What about this one? No. Which means this should be equal to this. Yes. If we remember that our principle. That means that the second force, which is mg, or we call it another name for mg is what? Weight, right? Yes. Should be equal to the normal reaction, or you call it force. Please, what I'm giving you are steps, tips to this before we start our Mmanu method. Now, the second thing is to identify the torques. The second thing. So, what we say in this case is that sum of forces equals to 0. That is what we've done here. So making sure that the left-hand forces are equal to the right-hand forces and upward forces are equal to downward forces, it simply means sum of forces equals to 0. The next thing is to do sum of torques equals to 0. A man fear in a textbook. In fact, if you go online to learn what I'm about to teach you today, you will not learn it. It's not making mouth. I know what I'm saying. By the time we finish, you will come to understand and you will see questions. You go and check it out. Sum of forces equals to 0. That's the first step. The second rule, sum of torques equals to 0. So now let's check something. Do we remember? I don't have to be defining torque again. We'll pass through that stage. When we start doing new student class, we'll repeat it for them and we'll do it today. Now, do we remember that? Do we remember that torque is equals to RF? Shebi? But this RF is when force is at 90 degrees, right? Or when distance is at 90 degrees, is it not? Do you agree? But what of a situation? What of a situation whereby distance or force is already inclined at the plane, which is this inclined plane now? Notice, when he has to do with that our normal case, where we normally have something like this, we'll come and have maybe, they say a force this way, or maybe a force going this way. You see that we already have 90 degrees for the distance, Shebi? That is going this way and going this way now. Horizontal, vertical is already at 90 degrees. But a situation whereby our force is now this way and our distance is now this way. Understand everything I am saying, it is leading to somewhere. Can you hear me? A situation where I am now having force instead of the usual. That time we started, here we have beams. We have maybe distance this way, a meter rule. Force this way or upward, everything normal because it's already locating 90 degrees for you. But situation where I am now having like inclined plane now, which is why we say linear ladder problem. The ladder is now here, having the distance, and we are now having forces going this way, or forces going this way, or as it's like this, forces going this way, or as it's like this, forces going this way. These are the cases, the 4 cases of inclined plane or linear ladder problem. So you can see that when we are talking about the weight, is this way. When we are talking about the normal reaction, is this way. Is it not true? When we are talking about friction, is this way. When we are talking about reaction on the wall, is this way. Are you seeing it? So what it means is that in this case, how do I make the force or the distance to be at 90 degrees? Because torque is the product of perpendicular distance and force. Is it not true? Or product of product of distance and perpendicular force. That's what I said. It's either you put it torque to be product of perpendicular distance and force, or product of distance and perpendicular force, whichever way you want to put it. So how do I make these 4 cases to give me 90 degrees? That, which one? All right, calm down. But please, see what I'm saying. Notice Nina here in this inclined plane. All the forces that you can have on this inclined plane can only be in this case. So how do you rotate? How do you have this now? When you have this thing now, this way, you see that I will need to make sure that this distance goes to 90 degrees in order to be able to talk about torque. Are you seeing it? When I have this one, I will need to make this thing to go here so that it will become 90 degrees. Are you aware? When this one is this way, I will need to make sure that this distance is rotated to this way, brought to that component in order to talk about torque. And when this one is this way, I will need to rotate this to come to this in order to talk about torque, because torque has to do with 90 degrees. So I said this case is a case where I am looking at the frictional force. You trying to break it down like she asked me is of no use. The use is you getting the compounded information. But all the same, this is the reaction on the wall. This is when I'm talking about W weights. And this is when I'm talking about the normal reaction. Now please, before I teach you how to get all these things to get torque, I want you to write Mmanu method. Write Mmanu method as a short topic here. So I'll give you the Mmanu method, the easy way. Then as I give you the easy way, when I come and prove it, how we derive that easy way. Can you hear me? Hello? As I give you the easy way, when I come and derive how we got it to be that easy way. Now please, any force, keep quiet, keep quiet. Any force Any force that is on the y-axis, once you see a force on the y-axis, is this force on the y-axis? Is this force on y-axis? Is this force on y-axis? Any force on y-axis, I told you that once you are dealing with inclined plane, y-axis becomes cos. Shebi? Shebi? Any force on the y-axis must carry that particular distance of the ladder. Call it LO, the LO distance. Cos theta. Are you getting the point? We'll prove it. So remember that the y itself, let's say for example, we are talking about this weight, Shebi? We are talking about this weight. In order to get torque must be perpendicular distance of perpendicular force times what? Distance, Shebi? So the Mmanu line is what we are doing, and then I will now prove it using this, adjusting to show us why. So what it will simply be that to get the torque when the weight or the force is at vertical, whether it is downwards or upwards, what it will simply be is that the torque will simply be equals to, let's say I'm talking about weight here, the weight itself, then the distance, that distance is not at 90 degrees, hope you know. Shebi, you know. So I have to find the components. Anytime something is not at 90 degrees, I have to have it to be sine or the cos of it. Is it not true? So provided you're seeing it at vertical, you are going to be putting cos theta to it. We'll prove it. We'll get the second one, we'll prove it as well. Remember I said that for inclined plane or simple pendulum, y becomes cos theta. X becomes what? Outside it, normally x should be cos. Should be? Y should be? We'll prove it, but just write it. Now, when I see that I am talking about the x-axis, something going this way or going this way, no matter how it is, that thing is going to be carrying half or maybe 1/4 or whatever quarter of it, because if actually that particular thing is at the middle, it will carry half of, remember it's distance we are talking about in this case, Shebi? Let's say as I have this thing, this weight now is acting in the middle now. Is it not true? So the distance for this weight will simply be from here to here or from here to here. Do you agree? So it will simply be the ladder divided by 2. But if maybe I am considering, let's say in this case, from here now, notice everything here, there's no half on this, Shebi? So I will not consider half. So in order not to use the half to confuse us until we start a question, let's ignore the half. Let's use the full distance so you know it. So when it has to do with x-axis, I will simply put that particular force I am considering. Maybe let's say reaction of the wall, because that's an example of horizontal here. It will not carry sine theta. But notice that this is reaction of the wall. What about the L, the length? Hope you remember what torque is now. Yeah. So this thing is the same thing as saying all the forces times all the distances. This 90 I'm putting here is in order to make it to resolve to 90 degrees, because it's not at 90 degrees. Now let's prove it. Am I too fast? Yes. Did you understand? No. Okay. It's alright. It's alright. I should start from here. Okay, sum of torque equals to 0. Okay, from here? Yes. Or from here? Okay. But I hope you know that we've not actually started summing up the torque. Shebi, you know. What is it doing you? See. Up to this point, do you understand? Guys, I just drafted out the forces from this place now. Here, for RW. Do you understand that one? Yes. Here, to this place for N. Do you understand that one? Yes. This thing for MG. Do you understand that one? Yes. For MG now, wait. MG is weight now. That is coming up this way. Notice, coming up this way and then going up. Or you say, as it's coming up, it's still coming this way. You should understand that one. Then for any going up, and then taking this. I just drafted out the components. Is it the any? It's still the same thing, but let's draw it the way you like it. So N is looking this way. N is looking this way, Shebi? Yeah. So it's the same thing as saying I have it To get it to 90 degrees, I have to put this one back. Shebi? I am now saying, I've not solved anything. What I'm saying is that you should note. Then when I come back and prove it, I am saying that you should note that since torque is the product of perpendicular distance and force, right? Shebi? That anyone that is happening at the y-axis, because it's at an inclined plane, on an inclined plane, y-axis is what? Cos theta, Shebi? That you should just do torque cos theta. That is what I'm saying. Anyone on y-axis, just do torque cos theta. Are you seeing it? And anyone on the x-axis, just do torque sine theta. We will now prove it. So that is just what I'm saying. So I'm saying that since this thing now is at x-axis, Shebi, that the torque will simply be, if I want to do this, I will get FF, and then the distance L, because it's at x-axis sine theta. We know that x-axis is anything like this now. And that when I am doing, because here need a neighbor of torque, then put sine theta to it. If you don't understand how to resolve, we'll not do it. Now I said that when you notice that it is going this way, for example, this W is going downwards. Shebi, I am now saying, because it is going at vertical, which is y-axis, at vertical, which is y-axis, just say torque, and y-axis for an inclined plane is cos theta. Is it not what I said? So do torque cos theta, which is the same thing as saying W and L. Is this thing not torque? Force and distance, Shebi? Put cos theta to it. Do you understand this one? Do you understand this one? Open your brain now. This yes and no that you people say is because you people have gotten to the habit that sound was forced it inside. Try small. What I'm saying here is don't think again. Don't even think again. Just tell me that on an inclined plane, y-axis is cos theta, x-axis is sine theta. Shebi, that when I'm now dealing with an inclined plane, that I should now have torque, that is the weight or the force, and whatever distance I have there, when it's y, just add cos theta to it. And when I'm dealing with the x-axis, just do torque, that is whatever force I have there and the distance, add sine theta to it. Do you get that one? Let's now prove it. There's no what if, even if there are two forces, provided, I am not saying what if, I am saying provided, no matter the number of forces there, do this one I'm telling you. What if does not come here? Provided is on the x-axis, do the torque, that is the force and the distance, you add sine theta to it. We'll still show you how to derive it, which is what I'm about to do now. Now I said that if you notice that it is vertically, just do torque, that is force and the distance, add cos theta to it. It's not hard to understand. This one is so you know it. Oh. Anytime you are solving a inclined plane problem, you don't need to get it, you just know it. But we'll prove it so that you cement the understanding now. So you cement it. In case you enter there and you want to forget, let's now try to cement it. I want to clean this. If you like, be doing what if. When I've told you what you should do, let's prove it. Be doing all the what if. If you like, let the forces be like 100. Let's say 2 people climb the ladder. Let's say 100 people climb the ladder. Their weights are acting downwards. It's vertically downwards. It should simply be their torque and their distance because it's y cos theta. Simple. So let's check it out. I want to clean it so that we now prove all these things that we've gotten here. Let's prove it, please. Let's prove it. Then we take examples, we go home. Then the new students will stay back. Oh yeah, see. Look at this. We've drafted this first. That's the first rule. For the second rule, sum of torque must be equals to 0. If sum of torque must be equals to 0, see what I am going to do now. I'll bring my inclined plane. I bring my inclined plane. I bring my N. I remember that anytime we want to do a particular torque, we normally make one side pivot. Is it not true? So it's either I'm making this side pivot. I will make this side pivot. Do you know why? We'll start with this as pivot. Then when we are done, just the way we did that day, when we are done, we'll come and make this one pivot as well. I'm starting with this because most of the questions always ask you, find the reaction on the word. So what I'm going to do is make this side my pivot. Pivot, pivot, pivot. Now notice, I have the weight acting downwards, mg. Then I have reaction on the wall, RW. See what I will do. Angle, I've told you, this angle here is going to be theta. If they tell you angle is made with the horizontal, that's where it is. If they tell you the ladder makes an angle with the wall, that means it's simply angle with vertical. I hope you know. Yeah. But I now said, when they did not mention where angle is made, whatever angle given, you consider it that it is with the horizontal. Note all these things. Note all these things I'm saying. These little things that looks as if it doesn't matter. Very important. Now, I am saying, to consider the torque in this case, we normally make one side the pivot. We now start considering. I'll ask myself, if I have this, and I have this, and I have this, do you know that this thing I'm having here is theta? This triangle I'm having, remember we are dealing with equilibrium. This triangle I'm having is also here. Once you are not able to understand why it is called equilibrium, you will find this course hard. Do you agree that this is also this? Yes. And this angle is here. Do you agree with me? Yes. Do you all agree to that? Yes. If that be the case, do you agree with me that this thing is my RW? Yes. Shebi? Yes. This is also my RW. You agree? Yes. Do you agree with me that this is my N? Yes. But let me not look at N now. I want to consider RW. And that is to consider the torque, that side. That is RW times the distance. And since it's vertical or horizontal, I should have sine theta, Shebi. That's what I'm saying. Is it vertical or horizontal? Sorry. Horizontal. So since it's horizontal, I should have what? Is it true? Yes. Okay, but let's check. Let's say I am carrying this thing now. This particular thing I'm having here. Listen, Shebi, this is the angle. This particular angle. Let's say I am carrying this particular thing. That is, remember that this is the distance. Yes. This is the distance. How do I make this distance? Notice, I have it like this. Watch, so you don't think I'm playing magic. I have it like this. How do I make RW, which is the force, and look at the distance here? How do I make this thing now to become like this? To be 90 degrees? I have to carry it like this and go like this, Shebi? Yes. Open your eyes! If you look, you think your eye is failing you, you open it well. Because sometimes the reason you are finding it hard to understand is that you are not opening eye enough. See, I have this thing here, and Doug is saying that every force or distance I have, that one of it should be product of perpendicular distance. So since this thing is not at perpendicular distance, how do I do this thing to be like this? This is what I'm looking for. Because the RW is already in a position I want it. I don't need to start bending it again. It's the distance I need to now adjust. So how do I make this? It's either I'm moving this thing like this when I'm using this up. Is it not true? Yes. And notice that this angle is theta, Shebi. Yes. Do you still remember ASTC? Yes. Away from the angle. You sign, Shebi? Yes. So if I'm opening this thing now, am I opening this angle? Yes. So it's going away, Shebi? Yes. So that means that I will have RW that is here, this RW. Knowing what torque is. Now this is the length, L, and this L, taking it to half 90 degrees, is simply going away from the angle, Shebi? Yes. And away from the angle is what? Sine. I come and put L sine theta. Very simple. So if you don't want to suffer doing this thing, what you just need to do, that is why you're a tutorial student. Why I'm doing this is so that you get the proof. But for the fact you're a tutorial student, once you see it at X, just say X-axis when it's inclined plane is simply sine theta. Just say, but torque is simply force and perpendicular distance, Shebi? Or this perpendicular distance and force. You just carry torque. Come and add sine theta to it. That is that one for that side. Well, let's check for when we are doing any now. Let's check for any. And you also know, assuming I did not consider this one, and I want to consider this one down here. As I'm having it this way, and I'm having it this way, and I'm having this way, and I'm having this way, theta this way, and I'm having RW this way. If I also said, let's now take this thing, because the situation I want to have is simply, since I have RW this way, I want to have a situation where, as this thing is this way, I should have another one this way. Yeah. Hope you know. Yeah. Because it's already at a position I want. I want to have horizontal and vertical to achieve that. So I'll simply say, carry this thing to here. And opening this thing here, you see that the angle is opening. Whichever way you do it, it's going to give you that RW times this length. That is the ladder itself. L for ladder. L for ladder. So L that I'm opening, and it is opening at an angle. That angle is the component to make it 90 degrees. So it will be sine when I'm opening. So let's prove for when it is horizontal. So this is the reason why I said, once the angle is at horizontal on the inclined plane, just consider it to be sine theta. Oh yeah, let's prove for any. Let's prove for any. Can I clean? Oh yeah, now fast. Just copy small, fast. So that by the time we've gotten it, so we've gotten that RW. Let me write it one side. We've gotten that RW. That this now, to get the torque here, the torque on this, the T here will simply be equals to RW, that is reaction of the wall times length, then sine theta. So let's do for this end. We do for this MG. We solve questions. You don't have any problem again. Anything inclined plane, linear ladder problem, sorry. So when we finish this linear ladder problem, I now teach you forces acting on an inclined plane. Then when friction is there and when it's frictionless, how do you solve it? We'll prove the formulas, we'll solve questions, and that will be it for equilibrium. Yes. So the only time we do equilibrium again is our normal Wednesday and Friday class. Some students will come and ask me, sir, how do we now cover up for the new students? I normally say, whenever it's new students class, your business is attend. You hear there's new students class, your own business is attend. Your limitations are not my limitations. For example, do you know if I stand here and say I want to bend down and pick something here, it will be hard for me. But there's somebody that will come and stand as I'm standing here, rotate himself like rubber, and pick that thing. If it maybe add small guy to it, there is small guy to it, while picking the thing, you will think it's so. Limitations differ. Your own is if we announce new students class, attend. Okay, let's continue. You've copied. No. You've copied this one now. Yes. So if I want to now get. If I now want to get the n here, remember we made, okay, first, before I come to this n, I'll not do n because we made n my pivots. Do you still remember? Let's get all the torque from this way coming down. Let's get all the torque from this way coming down. So that if we want to get n now, it is even easy for us because whatever we get for this one, do you remember is equals to this one? Shall you remember? No need stressing ourselves when it's linear ladder problem. So let's try to look at it. So I have, let me draw my slope again. Once you are not able to always do, if this triangle is here, remember there's another triangle equilibrium to it, you will not understand this course. That is why if you go online and watch so many videos they have there, none of them will have, they know it, but they will not have that time because they believe that basics is very too fundamental. But you man that don't know that basics, you want to start doing the advanced level, you are stuck there. At a point you start saying, what is these people doing, sir? What are these people? So it's because of these basics. So if I draw my slope again, and I want to consider my n. Now I have this theta. Even if I don't have this theta here, I have it here. We can still solve. So I have my theta here. If I have this theta, notice that the weight of this body is acting this way. Is it not true? Anywhere the weight is given, they will always tell you. If they tell you the weight is acting 2/3, it simply means whatever you are given, you should I say, multiply it by 2/3 of it. Because you will definitely be given a length. So if that be the case, we are still illustrating. We've not started solving an example. This is my mg. Notice, this mg is happening at where? The center, Shebi. This ladder from here to here is the full length, Shebi. If I have it to be maybe 20, that means that the mg here is acting at what? 10, right? That means this particular force, this thing is a force. This force is actually acting here and also acting here. It's not acting on it like fully. So if I'm considering this particular force acting at the center, it's more like I'm saying I'm doing to this side, I am doing to this side. You don't come and say that is the full length, no. So it's now depending on the particular axis you want to consider. So we say at that center point, see what I mean. If a force is acting here, I can consider the full length. If a force is acting here, I can consider the full length. But if it's acting at the center, I am just giving it from here, especially weight, downwards. I'm just giving it from here, downwards. So if that be the case, I will remove my eye here because weight has nothing to do with up, downwards. So for that reason, my L in this case, when I'm considering the center, that is the gravity, the weight, will be L over 2 and no longer length. So if that be the case, what I will now simply do, in order to find the torque on this, remember that this is still my pivot. That is, this part is still my pivot. We normally make one side pivot from when we started this class. We normally make one side the pivot. So if this is now my pivot, what I will simply do is to remember. I go back to my drawing table, which is the method that will make you always get this thing. My drawing table is to say, is it not equilibrium I'm doing? How can I have one triangle? I should have two triangles to prove that I'm doing equilibrium. Triangle that is equal to it. Oh yeah, this thing. If you like, think it's a joke. See, you enter exam hall, you forget that shortcut I gave you. You now start to prove it. Head will be doing your moro inside hop. You don't know that, eh? Sometimes, if you are writing an exam, if you check your hand, the amount of water you are producing, will be enough for you to drink. Some people's hand during the exam, if you see their hand, water everywhere. Yeah. So now see, if I have this angle here, hope you agree that I also have this angle here. Yeah. Now remember that I have this force acting this way. Please, do you know that this thing I have here? Is more like running through. It's also here. Do you agree? Yeah. That horizontal line is also here. Hope you know. Yes. It's also here. It can be everywhere. Now, do you know that this angle is also here? Do you know? Spiritually look at it. So what I'm saying in essence is, see what I'm saying. This triangle, see what I'm saying. I'm saying if this is the mg, and this is the ladder, and this is theta, if this is this mg down, and this is theta, I'm no longer considering the full thing. I'm not saying consider this and consider this. That is, I've drafted that half. Take that half. That is from this end. You now see that this is that theta. Are you seeing it? Yes. What I'm now saying is to resolve this particular force. Remember that mg is already like this. Yes. And the distance, which is the ladder, is this way. Is it not true? Yeah. I need a situation where this thing now will not come and be this way. Hope you know. I need a situation where I will have the force mg and the ladder, which is the distance, to be this way. Are you seeing it? So how do I resolve, what I'm saying is, how do I resolve this particular thing to come here and give me this? If I carry this thing now, notice that this one is already here. If I carry this thing now to up, this is the angle, Shobi. This is the angle now, because this angle is equal to this angle. QF, the reason why you should do this equilibrium. Do you know that if somebody puts his eyes here, and you are saying you are opening this angle, what you are doing is that if your eye is here, you are not remembering this thing. You are doing what we call massive destruction. You are breaking, scattering things. So what we are doing is that we are taking it that since this angle is this equal to this angle, if we are taking this thing now to this place, this angle is closing. Are you seeing it? Yes. Look. 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 So what you need to consider is that you must understand equilibrium to the point where you are getting to the point that you say, if I have it to be this way, it is this way. That is why I did not rush to start teaching you this one before, without teaching you the first step. And those first stages, I tested your ability to understand if it's this side, it's also this side. So I don't just come to teach you. Well, maybe if I'm doing my own, you that know too much, you are doing your own. You've read before me, so you are on that side while I'm still this side. It's good though, but please, we need to be taking it step by step. So the reason why I taught you that you have to always remember that once it's here and it's here, it is the same thing. Ask your question.
This word that is said is like half of the length of the ladder. If they give us like the length of the ladder from the foot of the ladder to the wall, are we going to divide that one also?
If they give you length of the ladder, yes, from the foot of the ladder to the wall.
Yes, are we going to divide it?
Shall you see? Say shadow. Say shadow. Say shadow. I will not be faster than my shadow. Yes. See, if they give you from the foot of the ladder to the wall, that ladder is still having mass. Weight must be acting directly towards the center, downwards. So once you want to find the weight, anytime you want to find the weight of anything on an inclined plane, you must use this principle that we are using. Whenever you want to find the weight of anything on an inclined plane, you must divide the length by 2. That is what I say. You can say notes because weight acts at the center, downwards. You understand it now? So where you are looking at, I get your question, forget the joke I'm adding to it. It's a smart question. Let me throw light on it again. Where you are looking at is, if I'm considering from this end to this end, the full distance. In that case, when I'm considering the full ladder, the two things I'm going to be looking at is simply reaction of the wall. The two forces I'm going to be looking at is reaction of the wall and the frictional force acting down. Or maybe there's a friction on that particular wall. Maybe they poured oil on that wall and the wall really needs friction. So in that case, what I'm going to be considering in that case is now a situation where I'm having, when I'm considering full length, these are the things I'm considering. Reaction of the wall. Friction. That is, if this ladder wants to slip like this, friction acting this way, friction acting upwards this way, and friction on the ground. Are you seeing it? So whenever you can even note it. Whenever I am considering the full length, these are the forces I should be looking at when it has to do with inclined plane. So reaction of the wall, friction pulling it up, provided they tell me that it is frictional wall. Then friction on the ground. But if they say it's a frictionless wall, I have no business with this, which is this case for your level. These are the two forces I'm looking at. And however it is, you must remember I said that once it's y-axis, you do tug and what? And once it's x-axis, you do tug and what? Please, if you go inside the exam hall, you forget everything I taught you. You can just use that Mmanu and scale through. That's it. We'll still prove it when we start doing inclined plane. Forces on inclined plane. When frictional, when frictionless, we'll start proving it. You now start to see if there is friction. All those things like friction minus mg sine theta, why? Friction plus mg sine theta, why? Why is it that if I have a component going this way, the vertical axis is always equal to the horizontal axis? Why? That is mg sine theta. We'll prove all those things, but we have to learn this one before getting to that. So if I know that, let's complete this, our mg. How did we get? To which point? I will do it again. I'll do it again. But see, let me tell you something. Can you hear me? This is classroom. Can you hear me? Classroom. Tutorial class. Sometimes lectures, but this one is tutorials. Please, it is important that as we are doing this class, you pay attention, no distraction. Me, let me tell you the truth, as human beings we know you have limitations. Some of you, you've been very busy since morning. You go here, you go here, you go here. We all pass through university. We know how you feel. It's not easy. But in as much as that, as much as you go through all those things, you still have to now be preparing your body well, so that all the things you are facing, you can align your body to it. So you need, when we come here, no matter how tired you are, 100% attention, because people are doing it. You should do it too. So what I'm saying in essence is that I want to start this from the beginning. The goal is to make you understand. I am saying that if this is the inclined plane and this is the weight mg, the g is actually because of the fact that anything going downwards, any body has weight dragging it down, and that is due to gravity. You have the g. What I'm saying is that this ladder itself acts at the weight acts at the center. So you are considering the weight, the length from half of it downwards. So if that be the case, I'm having L over 2. And if I'm having L over 2, the next thing I am going to be considering is simple. This thing, notice that this thing I have here has formed a triangle. Is it not? Let's do it that way. I bring out that triangle. Let me just make it big so that we can all see. Bring out that triangle. The way I want to make math next year, I want you to really understand. I have theta here. Do you agree that this thing is mg? Shebi? If that is mg, now remember that this thing is that half of L now. So let me just write L over 2 because it's half of L. Let me write L over 2. What I'm now saying is that if I want to get the top here, that if I use just this triangle to do it, it will be hard for you to see where am I pulling to. Because notice that I already have this thing here now. I'm having this and I'm having this. Hope you know. That is what I'm having now. This is L over 2 now, and this is mg. Is it not? So if I know that, I could have said, let me come and put it here. Then you said that half of that is if this is this, this. But I don't want any confusion. I'm not saying that the same thing I have here. Can I also say that this thing here is the same thing with? Pay attention. See that girl? I'm teaching her, she's writing something. Oh yeah. Can I also say that this triangle here, you can pay another full attention to understand. There is an attitude to whatever you want, and that is fact. Oh yeah, see, if I make this, we agree that this, everything here is this thing. And this theta here, even if you don't want to understand it, we call it alternate angles. They are equal. What I'm now saying is that the minute you do this thing and you've gotten it to be equal, and you say that there's an angle here, remove your eye from this angle now. You have a principle you must use to be doing this. Remove your eye from this angle now. And since I have this thing here, remove your eye from this angle, this line now. My business now is, how do I make this mg to be here and this L over 2 to now be this way? Because I need 90 degrees. And why do I need 90 degrees? Because that is what torque is all about. It's torque I'm finding. Torque is perpendicular distance and force, or product of perpendicular force and distance. So if you see it that, if I'm to take this thing now to horizontal axis, notice that I will be closing this thing. Remember, towards the angle, use what? Hey! Who is saying sign? Incapacitated. All science students take coffee. Away from the angle, use sign. Towards the angle, use. So as I'm doing this thing now, he's closing this thing. So as he's closing it, you can now very well see that what I'm supposed to use here is going to be cos. That is why we started with resolution of vectors. For those of you that are new students, you don't understand vector, no problem. We've not done vectors for new students. We'll be doing it today. So let's go back. Back to business. Back to business. Back to business. Oh yeah. See, watch. So the torque here will simply be equals to this mg, that is force. Torque equals to force and perpendicular distance, or perpendicular distance and force, or Distance and perpendicular force. So mg times the distance, which is this L over 2. And the angle to get 90 degrees is what? Sit down. Very simple. Very simple. So I am saying, my students, instead of you suffering yourself to check all these things, there is no time. Can you hear me? You don't have all the time in the world. The only thing you just need to do is to say, when it has to do with an inclined plane, academic daddy said that if you like, go around this world and come back. For simple pendulum and inclined plane, y-axis must always be cos theta, and x-axis will always be very simple. So just do the tug and add all those components. Very simple. So with that said, I can now come here. Notice that I found this one and I found this one. Remember we made this one our pivots now? Yeah. So to find the torques coming from this end to this end, what it will now be is simply, I will say, my RWL sine theta is equals to, do you know what I'm doing here? No. This is the center I'm saying, sum of torque on the horizontal axis is equals to sum of torque on the vertical axis. Very important. Very important. Because I've told you, when we are learning in tutorial class, if you are reading, it's okay for you to read and be seeing plus, minus, or whatever. But I'm telling you that as a student that passed through this tutorial, you don't need all that. Your own goal is to always make this equal to this. This equal to this. So making sum of torque on the horizontal equals to vertical axis, what I will now have is this RW sine theta that I got equals to mg L over 2 cos theta. I see here, to make this easy for us to understand, we will take an example from your textbook. There's an exercise. Check the PDF I posted on the group. If you check that group, please, for your level, I know some of you like reading too much. When you go home this night, what you will do is now, you can be killing yourself. You start browsing linear ladder problem, frictionless. You don't need it. The only thing you need at this year one stage is just when it is frictionless. Examples like that one we are going to treat. Why am I doing this? So you use your time well. And I also posted some questions on that group. So you use your time well and focus on the ones that are frictionless. Focus on the ones frictionless. Use your time well so that you will be able to do things like gravitational force. If you're able to cover your scheme of work times 2, and you are very knowledgeable, you know that there is a way you read sometimes. And if you really get that intuition, you start feeling like Isaac Newton, like him. He always postulates his own formulas in class. So you start forming your own equations, deriving ways to go around it. So use your time to see if you can know any topic so well that you are deriving your own concepts to it, rather than going to look for the ones you don't need. So let's look at that last exercise on that equilibrium exercise. Let's solve it. Then solve some questions in your what's it called, workbook, and then treat concept of when I have n, making n the subject of the formula. So please check that question for me and read that. So I ask, can I clean? We have to be fast so that we can do new students tutorial class. Please see. Go to Esut Men Freshers group. You will see equilibrium moments and check that thing is from your textbook, is your textbook exercise. If you go to that textbook exercise, not the one, I will treat that one that has 2 things balanced on it. I will still treat it today. But before that one that has 2 things balanced on it, that is getting force to maintain equilibrium on it. Check the other one that has something like linear ladder problem. Read it out. Did you start with us? Yes. Okay, how I got RWL sine theta? Yes. Who else wants to know how I got RWL sine theta? Who else wants to know how I got RWL sine theta? Okay, please, if up till now you don't know, see what I want you to say. RW, see. Please, Shabi, this is our RW. Is it vertical or horizontal? Horizontal, Shabi? Hope you know that this ladder is the distance to this force. So since this force is at horizontal, if you don't know how to derive it, just say it will be RW. It is having the whole length. I'll have LO. Anything that is horizontal when I'm doing inclined plane should be what? If you don't remember it, just remember it this way. Can you hear me? Horizontal. Once you look, you say it's an inclined plane. You say horizontal axis on an inclined plane is known as sine theta. Are you saying it? Then we are treating torque. You just say the force and that distance, sine theta. So please, is the sentence as saying torque sine theta equals to horizontal axis. Torque cos theta equals to vertical axis. Very simple.
They use that away from science.
I've done that and I don't want to do it again. I want to, but see, if you don't understand it, as we solve the question we solve now, it's the same thing. You pay attention, so you get it. This time around with question. Now pay your attention. Always pay attention. Okay, so please, write down the question inside your notebook. Shebi, this one is my own. Okay, you're the one that came today, Shebi. Okay, please, write down that question inside your notebook. Right? Guys, give me your phone. Just go to Student Freshers Group, let me see. So that's my name. Jennifer. I always see you in class, and you are being very attentive. Never go can now forget in class. I saw you that attentive. Please, number 8. From that PDF, number 8, a uniform ladder of mass, 100 kg, leans at 60 degrees to the horizontal. So then I say again, if they send to the horizontal, it means this type of thing. If they send to the vertical, it means up, Shebi. But they did not tell you at an angle, they did not tell you if it's horizontal or vertical. You are using the horizontal. Very important. You will see cases like this, and if you don't remember all these things I'm telling you, it will be hard. So they said a uniform ladder of mass, 100 kg, leans at 60 degrees to the horizontal. Yes, they gave it to us now, yes. The uniform ladder of mass, 100 kg, leans at 60 degrees to the horizontal against a frictionless wall, calculate the reaction on the wall. Please, see if you can get it, then we'll do it together. When I'm doing it, those of you that did not understand the first concept, I will slowly, gradually do it. So understand. So let me repeat, I said, a uniform ladder of mass, 100 kg. A uniform ladder of mass, 100 kg, leans at 60 degrees to the horizontal. You will see it in the textbook if you have textbook. It's the last exercise of the textbook. You will see it in exam, but they did not teach it inside that book. A uniform ladder of mass, 100 kg, leans at 60 degrees to the horizontal against the frictionless wall, calculate the reaction on the wall. A uniform ladder of mass, 100 kg, leans at 60 degrees to the horizontal against the frictionless wall, calculate the reaction on the wall. Question 8. If you have your physics textbook, is the exercise 8 there. It's the last exercise there. You said there's no L. What did they give us as the length? Let me see. Okay, they did not give you L, Shebi. The ladder itself is L and length. See, if they did not give you L, the ladder, I'm coming, my friend. They did not give you L, the ladder now is L now. See what I mean, see. If I have a ladder and I don't know the length, I can easily look at it and say from here to here is the length. Is it not true? I can use L for it, or you say height, but use L, the length. So if I want to get to the middle, it is now the full length divided by 2. Don't worry, we shall see. Push yourself. How do you have to leave this wire? But let's do it together, sharp, correct? Yes. Isaac Newton got it. He's the AI of 2025. Who is that? You come and check who? Then if I hit you look like people when they get first class medicine. Serve you. Keep it up. By the time you finish medicine, it will look as if you just entered the one. That's when you will now see that people looking at you will think that's when you just entered school. For now, they will think you're primary 6. For that time, that's when they will think you just entered school. But see, let's calm down. Let's calm down and see if we can do it together. I will take it small. Eh? Let's do it small. Let's do it small. Everything we are going to be learning this semester, we must make sure you understand. That's my promise to you. Everything we are going to do this semester, understanding is the first thing. Understanding is the first thing. Shebi, you know that now that I've learned this thing, me using the normal method is because I'm still teaching you. As we progress, when we start solving past questions, I won't have need to be pushing or showing you all this. We'll just use all those our Mmanu. Y-axis cos theta, x-axis sin theta. But now that we are doing normal, we'll do it the way so that everybody can follow it. In physics, you do Mmanu. In mathematics, you do ASAP. And I know Master Toka will teach you that. Oh yeah, see, they said that ladder. Let's say this is the ladder. Please watch. Let's say this is the ladder. Now let's say this is the wall. Let's say this is the wall. Let's say this is the ground. Let's say this is the ground. The next thing is to ask ourselves, what angle was given? That's the first thing you check. Because you don't tell me what if they did not give angle. If they did not give angle, you are using theta. That means they will give you every other thing, or they will make sure that it's only one unknown. But angle must be there. You must know the angle. Because you cannot place this ladder without knowing the angle. So in this case, they gave us 60. Shebi? Yes. 60 degrees. Assuming they said it is with the vertical. They said angle was made with the vertical. Maybe they said 60 degrees with the vertical. What I will do is to say, since I like using with the horizontal, I'll just come and call here 30 degrees. Hope you know it's valid. I use it peacefully. So, if I know this, let's say I call here 60 degrees, because no distraction. Forget about writing notes. Let's see if everybody can understand this thing. Forget about writing notes now. I'll be taking it gradually. Once I want to do or overspeed, you'll call me. I apply brake. So 60 degrees. What is the mass of this ladder? 100 kg, Shebi? That means because of the mass, as a physics student, I'll just try and locate the center for my weight. The mass of anything causes it to have a weight directed towards the center, downwards. So I just gonna say, if this is the mass, 100 kg, that means downwards, I have 100 times 10. Somebody else can use times 9.8. Me, I want to use 10, which is 1,000 Newton, Chevy. Do you agree? Yes. So you see, I've not started doing anything strange. So the minute I do this thing, do you know the next thing I will do? I will now come and ask myself, what are the forces acting on this thing? Because I want to get torque. I want to get torque. It's torque that will help me get the answer I'm looking for. So in order to do that, I have to get all the forces acting on this. So I will say, right here, there's a force acting on this, because for this thing to be here, and they did not tell me that the ladder, after hanging it, it now slipped and fell down. It simply means that frictional force is holding it. Are you saying it? Like as the wall is frictionless. The wall is frictionless, not the ground. Can you hear me? Yes. Even that wall that they say is frictionless, all of us know that friction is still there. But what they are saying is that we should treat this without considering friction. So if that be the case, as this thing is here, trying to go like this, the ground, the wall, or the friction on the ground will be moving it like this. They will balance. Now, everything standing, Isaac Newton told us that to every force there is equal and opposite reaction. The third law. So for that reason, as this thing is here, there's a normal force as it is on this ground. This ground itself is exerting an upward force on it. We'll still even do that thing when we start doing fluid dynamics. So let me write N. I'm using N. Now, because this thing is resting here, as it's pushing this thing, together with what friction is doing to it because of this one, as it's pushing, this wall itself is giving it a weight back. Assuming this wall is not giving it a weight back, let's say the force here is greater than this wall. Hope you know. Yes. Because there's force here, it is holding it back. That means there's force on this, pushing this back. So I won't draw it here so you don't mistake it as part of the diagram. So I'll have a force on this way. We call it a reaction of the wall. Reaction of the wall. So because it's frictionless, I am not going to be saying that as this thing is resting here, coming this way, that there is also frictional force going this way of the wall. I won't do this. So what we are saying is that anytime we are treating linear ladder problem, as a student of this university, that we are not treating linear ladder problem without the frictional force of the wall. So I am not looking at this. Now, if that be the case, I will now ask myself, what are the forces here? That is the first thing I said you should always do. Find the forces. Because you cannot talk about torque without knowing force, then without knowing distance. So what are the forces? I know that the force will be the upward forces. The upward forces here will simply be this one now, shall we? The N. Upward forces should be equals to downward forces. So it should be equals to the downward force here is what? Only mg, which is what? 1,000 Newton. Okay, now the vertical or the horizontal forces, sorry. The horizontal forces should be equals to, yes, that is sum of horizontal force is equal. So left horizontal force equals to right horizontal force. So let me use this. I'm using these descriptions so that as you are reading, it's easy for you to remember. Equals to right horizontal forces. So notice my left this way is RW, shall we? Equals to, going this way is what? Frictional force. Please, when you are doing this, it's not that you are finding anything. What the essence of this is, let's say you have another question, the advanced level where you finish finding friction or reaction of the wall, they might ask you find the frictional force there. So provided you know this thing, whatever your RW is in that case, let's say they tell me to find frictional force, and I know that frictional force is also always mu times n. Should you know? That is normal reaction, is it not true? So all I will now do is that this RW should be equals to this as well. Let's say they give me a normal reaction, and I have the coefficient of friction in my question. It's the same thing. So we've not gotten to this stage. So if that be the case, I leave it at this. The next, root 2. Root 2. This thing is not hard. But here, this particular thing is under root 1. That is finding the forces. Finding the forces is under root 1. So now, root 2 is now finding the torques. So sum of torques. Sum of torques. So please, there's a reason why they call it tutorial class. It's a place for people to determine to succeed. So even if sometimes we plan a particular time and we exceed it, a water not tutorial. But have it in mind, for somebody that was asking me, what time exactly does the class start? The class normally is supposed to always start by 12. Because normally that's the belief that lectures end by 12. But most times lectures does not end by 12. There are some times when lecture exceeds 12. So whenever your lecture finishes, that's when we must start. And we cannot start when some people are having lectures. We must carry everybody along. That is why, for those of you that will always ask me, starting from beginning, we just started October. This thing we are doing is chapter 4. This thing. Upon the practicals we did and the fact that we always have to delay, so you understand. But covering is not an issue, which we've done countless times over the years. From January, we are starting from the beginning. But why we started from the beginning for newcomers this period is so that it will be easy for us. Because some people will still resume that January. So it will be easy for us. Beginning and trying to stay at small speed. Somebody will want to be dragging you back. So that's why we started for newcomers. So that by that time, it will be easier. So sum of torques, please. To get the sum of torques now, remember they asked me to find the reaction of the wall, Shebi? Do you know what I will do here? Please watch. Watch, I will now, once I get to torque, once I arrive at torque, this is where I normally adjust my seat belt and start to say, if I have this triangle like this, please take it from me, a student that came to this class. Anytime you have this thing, in order to solve this question well, you must always think of this thing is equals to this. You will not find any YouTube video that will teach you this thing with this. That is why I said, in order to understand it, you must understand the basis of equilibrium. That if I have a triangle this way, it must be this way. You are free to check. If you check now and you find anyone disprove me, that's the basics. And that is what makes it easy for you. So if I have this angle here, this angle is also here. That's the basics. So when I am treating, for example, any weight going vertically like this one that happened within the inclined plane, I must pay attention to the new angle. Can you hear me? When I am treating any weight or any force that happened on this inclined plane, within this inclined plane, notice that this one is here now, Shebi, due to the ground at the edge. This one is up here. Is it not true? So within here, it's highly important I pay attention to this new angle. So if that be the case, please, let's find RW first. You will agree with me that this is my RW from that diagram. Do you agree? That's my RW. Now what I'm saying is that if that is my RW, this is also my RW. But it makes more sense me viewing it from that place that I have my RW. So my goal now is to say, since torque is at 90 degrees, how do I make this RW and this ladder, this thing I'm seeing here is the ladder now. How do I make this weight, that is this force, and the distance, that is the ladder itself, to be at 90 degrees? How do I make it to be at 90 degrees this way? It is not simply by me saying, let me put this thing, Shebi, to this place. Do you agree? That is carrying this ladder from here to this place. By the time you carry this ladder from here to this place, you see that you've made it to look like this. And that is what torque is. So if I rotate this ladder, if I mounted that any down there to be the equilibrium, the fulcrum or the pivot. If I want to get the top and I rotate this ladder now to 90 degrees, I should have this. And because of me rotating this ladder to 90 degrees, what have I done to this angle? I opened it, Chevy. Is it not true? So, and remember that opening means what? Away from the angle, use sine theta. That means it's sine theta. So if that be the case, remember that this is RW. Torque is simply the force, product of force and perpendicular distance. And the whole thing I'm using here to open is the full length. Is it not true? The full length L and this sine theta now to show that. So because it's not at 90 degrees, anytime anything is not at 90 degrees, when I taught you resolution of vectors, if something is not 90 degrees and I have to take it to 90 degrees, I will show that I took it to 90 degrees by using that I took it to 90 degrees, that is on the vertical or on the horizontal, by using either sine or cos theta. That is what resolution of vector is. So I will come and put the sine theta I have here. That means that the torque on this is simply, and this thing now, notice, this particular force is on the y-axis, on the x-axis, is it not true? Yes. So I can say that the torque on the x-axis will always carry sine theta. So this thing is simply the force and the distance, sine theta. Now let's get for the other one. Let's get for the other one. Now my friend, they asked me, how did you get LW sine theta? Those my friends, hope you're getting it now. Please. Now, for me to get this one now, remember what they asked me in the question is to get reaction on the wall. But I must get the full forces now. The full forces from up to that particular pivot. Hope you know this is my pivot. So I must get, please remember when I taught you torque, you must get all the torques from that point to your pivot. I told you that if you have your door, for example, closed, and you have this to be your pivot, if you open this door from this place will turn. So you take it that when you are treating torque, what you are doing is you are applying force, and the distance as it's turning, the pivot is what is making it turn. So the same thing when I'm doing this, checking all the forces, the turning and rotation, what I'm placing, I'm mounting it at a particular end. You must mount at a particular end when you are not giving the fulcrum. Whenever fulcrum is not given to you or pivot is not given to you, you must mount your fulcrum at each of the ends. Then get all the torques from one point till that your pivot point. We did it in the first class. If you're a new student, panic not. Fear not, we'll get there. So please, in order to find the torque on MG, I want to draw it here. I'll still draw the same thing. I'll draw the whole inclined plane. And as I draw this inclined plane, notice, my MG is somewhere here. Please, I'm taking it that this is my MG, shall we? Let me project this. There's no limitation when I am talking about weights. It runs down. So let's say this is my MG. And this is my 60 degrees. I want you to understand this thing now. Because weight acts at the center downwards. So my MG running down 60 degrees. Now notice something. I have this my MG to be 1,000. Is it not true? 1,000 Newton. 1,000 Newton. Now notice the L here. Notice the L from here to here is half of this. Is it not true? That means that this thing is simply, once I do, if this thing is 100, 100 divided by 2 is 50. That means from here to here should be 50. So everything is simply L over 2. Now see what I want to do. I want to ignore my eyes no longer on the inclined plane. My eyes no longer on the inclined plane. Watch my eyes no longer on the inclined plane. I found a triangle with my MG. Gotten my L over 2. The minute I get this, when you learn this thing well, you don't need to clean. But I'm using this for you to have that mental visualization. The minute I do it, must, in order to get this course well, you must always do this thing. So equilibrium, since I have this triangle here, Shebi, is also equals to this. In Motamazi, as we start solving examples, we can now be easily doing this angle, that is using alternate angles, rotating it. But for now that you are learning it, Montier like this, do you not agree with me that the wire, Shebi, you see that this part looks like this part? Is it not true? If this one is standing like it downwards. So this angle here is this angle here. So that means that I have 60 degrees here. I have 60 degrees here. I am limited with regards to this, but let me say I have L/2. I have 60 degrees. Okay, now please, see what I'm saying? I wonder if you can see this. Let me make this big, please. People at the back, I doubt they can see it. So I'm redrawing it. You can see it, right? Hope you can see it.
Yes.
If you like, don't see it. I have the same triangle here. I have this here. How I wish you are learning this thing. I really wish you are learning this. I have seen this angle here is equal to this angle here. Sorry, just calm down. When you will be answering the question in exam, you will be happy. Yeah, I know you will be happy. So suffer now to enjoy that. I see 60 degrees, 60 degrees. The minute I get this one, the one for equilibrium, please, the minute you get this, when you learn it well, it will not be hard for you to now be saying, I will use this one, I will not use this one. Because as we progress, it will be easy for us to just be switching things. Yes. For now, because we are learning, that's why I'm doing all this one step by step. Yes. Please, take it that you're no longer seeing this line, because this line is here. So I will ignore my eyes, take my eyes away from this. Take my eyes away from this angle. Now, remember that this thing is L/2. So please, carrying this thing now, since I have something that is now looking like this, that is my 1000 Newton and the L/2. How do I make it to be at 90 degrees? It will simply be when I have this to be this way. So how do I do that? In order to do that, I am simply going to be carrying this thing now to this axis. And to carry this to this axis, provided you represent it well with the components, you are saying the same thing. So moving this now, am I closing the angle or opening the angle? I'm closing the angle, Shebi. And towards the angle we use. So what it will simply be say, the torque now will be 1000, that is force and distance. And making it perpendicular distance will simply be now cos 60 degrees. Are you seeing it? Yes. So if that be the case, I've been able to get this. The next thing I will now do is to now represent my sum of torques. So how do I do that? The minute I get this, I will come and check. The torques here simply, I'm having the horizontal torque, vertical torque. So sum of torques must be equal. So sum of horizontal torques equals to the vertical torques. So I will now have RW L sin theta is equals to 1000 Shebi. 1000 L/2 cos 60 degrees. All the topics you will do this semester, always eat before coming. Yes. We will squash all of it. Yes. Be playing. Can I clean? No. See. Ask me. Somebody say we are seeing. Don't see. Okay, wait, if it was leaning to the vertical, see, if it, yes, see, it won't have any effect. You know why? Because if something, for example, see, if something is, for example, leaning 60 degrees here, that thing is also leaning 30 degrees here. If I want, I can use this one. Maybe you know that since this thing is leaning 60 degrees here, it means that it's leaning here. Hope you know. No effect. So, provided you understand angles proper, I know that Master Doctor should do, what's it called? Circle theory with you people. You will get there. Inside that, in the university, circle theory is found under trigonometry. He will teach you other things under trigonometry. And the course, mathematics you're doing this semester is known as algebra and trigonometry. So he will be teaching you other things like radians. Sometimes here you see pi over 2. Let's be honest. What? Be playing. Come please. Let's be fast. Let's be fast. Let's be fast. What? Let's be fast. Wow. Have you copied? Yes. Copy. Let me clean this one. I can clean this one. Yes. You know it's because we did not start on time. Yes. That's the problem. That's the problem. Okay, I have RW L sin theta equals to 1000 L. Don't worry. After this one, we go home so that tomorrow we continue where we stopped. Hello, please, these students will stay back. Do you agree that everything here is essential with that? Do you notice that because I have Elu here, I also have Elu here? Child of God, listen to. Do you know why? You see vector, you see friction, you see equilibrium, work energy and power, gravitational force, fluid mechanics, continuity. All these things are things that if we don't treat properly, spend all our time on it. If you enter exam without treating it properly, darkness will be upon the face of the deep. God forbid. So we need to treat it well. That is why, since we are not able to solve as many questions as we can today, we won't end this course today. I was thinking we'll end it today. So that means tomorrow we'll still repeat this, but with different questions. Now that you've learned how to go about it, but we solve different angles of questions. Aya, please, can Elo cancel Elo? So now RW. Hope you know this thing now can come here, shall we? Yes. But since I want to make this also from over. Okay. Sin 60 is what? 0, shall we? 1000 cos 60. 500. Give me everything, let me see. 500. Okay, it's true, yes. Cos 60 is equal to sin 30. Yeah, you're right. Chevy? And that means this is 250. Equals to RW 0.8660. Divide both sides by 0.86660. You see what we have? So RW is what? Reaction on the wall is what? 288.68. Can you see the board here? Yes. 288.68, which is approximately 288.69. So reaction on the wall is approximately 288.7. in Newton. Unless you check the objective answer and you see 289. But if it's theory, but you know you don't meet the exam that is theory. So I believe you should see something like this when they ask you. So please, I was thinking that today's class I'll be able to treat linear ladder equilibrium, treat inclined plane, because we need to learn inclined plane as well. Then learn forces on an inclined plane. Then know the forces needed to keep an object on an inclined plane. That is, be it equilibrium, and when there is friction, and when it's frictionless. Which means we did not do any of that. We only solved one problem. So please, tomorrow's class I will make sure that we start with physics. Yes, because they have been cheating me. It's been mathematics. So tomorrow, when somebody pray for us, let us go. Somebody pray, let us go. No, why I did not do it? Because of time. So please, new students, remember to stay back. Please, new students, just 45 minutes. That's 45 minutes.